Years ago, is the universe eternal? Everything has an end, only the sausage has two. But what about our universe? Does it really have a beginning and an end? We don't know. Actually, our researchers thought that with the James Webb Space Telescope, they would finally be able to take a look at the mysterious beginning of the universe and find evidence of the Big Bang, the Dark Ages, and the first stars. But all they have seen so far are galaxies that are so old, so beautiful, perfect, and full of shining stars that they cannot possibly be baby galaxies in a young universe. James Webb also discovered massive black holes that combined more than 1 billion solar masses just 500 million years after the Big Bang. This means that they must have swallowed more than 1 billion stars the size of our Sun, or that they merged with other black holes and thus came to their enormous size. But all these sizes are beyond the scope of a Big Bang 13.8 billion years ago and the slow formation of matter. Let's take another look at Sears 2112. Luca Constantine's team found that this galaxy is about 30,000 light-years wide, which is about 1/5 the size of the Milky Way, has a mass of about 10 billion solar masses, which is about 1/100th the mass of the Milky Way, and has a star formation rate of about 20 solar masses per year, which is about 20 times higher than in the Milky Way. These properties of Sears 2112 certainly point to a young and active galaxy in a phase of rapid growth. Only the shape just doesn't fit. Is this now a definitive indication of the eternal universe and proof against the Big Bang? Constantine and his team say no. Galaxies grow like flowers. It's an exciting scientific thriller that's going on right now. Luca Constantine and many of his colleagues are trying to reorganize the cosmic puzzle. The Big Bang and Sears 2112 could fit together after all if we revise our understanding of the evolution of the early universe and also allow for new aspects of physics. Conventional models of galaxy evolution based on Newtonian gravity could provide explanations for new mechanisms responsible for the formation of bar structures and galaxies by including dark matter effects or by modifying the theory of gravity. Another possibility is that barred spiral galaxies are formed by the early inflow of gas along cosmic filaments into the center of young galaxies. This scenario would significantly shorten the temporal evolution of the bars. Perhaps intensive merging processes took place much earlier than previously assumed. Some theories suggest that hitherto largely unexplored galactic magnetic fields could play a hitherto underestimated role in shaping the structure of galaxies. Large-scale magnetic fields may have already contributed to the formation of bars and the regulation of star formation in young galaxies. Another explanation is that processes of self-organization in stellar clusters led to the natural development of bar structures without the need for external influences. This would mean that all the wonderful shapes we know from galaxies are perhaps a kind of natural growth process, just as the magnificent shapes of flowers, trees, or corals grow without us being able to describe them mathematically and physically. These new findings open the door to fascinating speculations about the nature of the universe and our role in it. The idea that the universe is not just a random meeting of matter and energy but is shaped by a deeper intelligent force goes beyond the old dimensions of our natural science. Such thoughts lead us to deeper and deeper questions about the origin and purpose of the universe and whether there may be a hidden layer of reality that we are now on the trail of, thanks to James Webb. Subscribe to the channel now and be part of every new video highlight. The James Webb Space Telescope found a galaxy exactly like our Milky Way, and this galaxy existed only 1.9 billion years after the Big Bang. This is a scientific puzzle because a galaxy of this age should be a chaotic and unstructured cluster of stars. This discovery raises fundamental questions about the history of the origin of the universe and the evolution of galaxies. It forces us to rethink our theories about galactic evolution and the time scale of cosmic structure formation. How could such a complex and mature galaxy form in a time that, according to current cosmological models, hardly offers enough space for such developments? A galaxy that was already as perfect as our Milky Way 1.9 billion years after the Big Bang must not exist according to the standard models. This galaxy turns everything that scientists knew and spread about the universe on its head. Now they are standing there with puzzled faces because the JWST, the new hero of astronomy, is serving up discovery after discovery that proves their old calculations wrong. Spiral galaxies are one of the complex forms of galaxy that form around a central bar of stars, from which spiral arms radiate. It supposedly takes several billion years for such a complex shape to even come close to forming. The Big Bang is said to have taken place 13.8 billion years ago, after which the universe was dark for a long time. With reionization, the universe became permeable to light, and the age of the first large stars dawned. According to the calculations of astronomers and cosmologists, the first complex clusters of stars formed at the earliest 1 billion years after the Big Bang. But even these first star clusters could not possibly have been finely structured or complex in shape. However, the newly discovered galaxy, which was given the name Sears 2112, is a perfectly formed B-spiral galaxy that can't be. But the universe and the JWST do not lie, so scientists must have made a mistake. But where was their mistake? What did they overlook that may be of the greatest significance for all of us and our entire understanding of the universe? Sears 2112, the discovery of a nightmare. How would you react if you pointed the best telescope of all time at a point in the sky to find confirmation of many theories you firmly believed in, and then you saw a disappointment? For many researchers, the discoveries of the Webb telescope are a nightmare. Nothing, absolutely nothing, in the early universe is as they had imagined. Our 100 years of astronomy and thousands of hours of work now simply gone. Generations of people have grown up believing in the Big Bang, the Dark Ages, and the birth of the first stars, and now we may be getting a whole new worldview. Dr. Luca Constantine is more relaxed about this development than many of his colleagues. The Spanish National Research Council postdoctoral researcher at the Centro de Astrología in Spain belongs to a young and open-minded generation of astronomers, and he is the man who discovered the impossible twin of our Milky Way. He and his team used the James Webb Space Telescope to study a part of the universe that should offer a very good view of the young universe as part of the Cosmic Evolution Early Release Science Survey, or Sears for short. In order to see the first APO of the universe, we have to point our telescopes at regions in the sky where there are only a few stars and galaxies in the foreground. With very long exposures of these regions, Webb can capture the finest traces of light from much further back and therefore older objects. Webb is designed to detect infrared light emitted by objects that are very cold, very distant, or very old. Among these sensational discoveries, Sears 212 was not initially one of the most exciting objects. It had a redshift of 3, which means that Webb had already found much older galaxies. But Sears 212 is a mystery in its own way because its shape and structure do not match its age. Simulations have shown that billions of years of galaxy reshaping and merging are necessary to form a barred spiral shape. The bar in a barred spiral galaxy is created by dynamical instabilities within the stellar disk, where gravitational interactions between stars cause matter to accumulate and condense along a central axis. These processes, aided by resonances in the stellar orbits and possibly influenced by dark matter, promote the formation of an elongated bar from which spiral arms can emanate. But these processes take billions of years. So what is wrong? Is our universe possibly much older, or did galaxies form much faster and differently than previously assumed? From a chaotic star cluster to a barred spiral galaxy, it sounds strange at first. According to measurements, our Milky Way is 13.6 billion years old, so it would have existed around 200 million years after the Big Bang. But this age refers to the very first structures. You can imagine them as a kind of very strong gravitational force in the fabric of the universe. This structure favors the formation of some stars or a cluster of stars. This is the beginning of a galaxy. The gravitational force later causes more stars to join them. A region of intense star formation may then form in the neighborhood. These two regions come together, and we already have the first larger cluster of stars. At the center of many of today's galaxies are gigantic black holes. Presumably, stars have accumulated around the first black holes, or the black holes have formed in the center of the star clusters. The gravitational pull of the black holes, the stars, and the entire collection of stars becomes greater and greater, and more mass and more stars come together until a galaxy is formed. Within the star clusters, further regions of increased star production are created through complex processes. This is how a galaxy grows as it moves through the cosmos. It encounters other galaxies in eons, sometimes they scrape past each other, sometimes they bypass each other, and sometimes they merge. In this way, a galaxy can grow to twice its size within a few billion years by merging with another. Incidentally, this will also happen to our Milky Way when it meets the Andromeda Galaxy in a few 100 million years and merges with it to form the Milkomeda. Galaxies with beautiful shapes as spirals, disks, wheels, or whirls are created by the complex physical interactions during all these processes. At least, that's how scientists have explained it so far. A galaxy that was a perfect barred spiral galaxy for only 1.9 billion years now blows all these old explanations out of the water. But how did galaxies form? These new discoveries shed a whole new light on the physical processes in the young universe, and we have to face up to the possibility that the universe may not have been young at all.